Here in this particular question, two charged particles P and Q having same charge but different mass MP and MQ start from rest and travel equal distance in a uniform electric field. That means what they're saying, they start from rest and travel equal distances in the uniform electric field. Clear? So suppose there is a uniform electric field and the two charges present over here. So assume that first of all we'll take two charges. Let it be charge and another charge here which are present over here. Charge particles is P Q. Here this charge particle having mass is P, having same charge, that means charge B. Particle is having mass and charge. Clear? Both are having same mass. They start from the same point. Most charges here. They are present in a uniform electric field. So let us consider where charge particle by equally spaced parallel lines. And here in this particular case, let it be by E. So in this field, when the charge particles are present, so then what will happen? They will experience some force on this charge particle along the direction of field itself. As these are considered to be positive charge particle, force will be towards right. Upon this, force will be towards right. Let the force be on B. Clear? So due to this force, what will happen? The charge particles will cover certain distance, and this charge particle will cover some distance. Also move some distance, same distance, but time intervals are different. Cover d distance, let it be d distance time. So this is the given information, and finally they are saying that find out the ratio of this, and also they are saying that gravity, neglect the effect of gravity. So if these charge particles are present in this uniform electric field, so then they will experience some force on the particle P, which can be written as F equal to QA. But force on this, as the charge particles are having mass, this force can be written as m into a. So that means mass of the particle into acceleration of the particle, that should be equal to Q into a. Then acceleration of the particle will be equal to QE upon mp. Similarly, the force acting on charge particle Q can be written as Q, because charges are same, electric field is also same, uniform electric field. But this FQ can be written as MQ into AQ, so that will be equal to Q into E. So AQ will be equal to QE upon MQ. One part. So due to these forces, what will happen? The charge particle will cover some distance. That means they will move under the effect of some force of electrostatics, and they will be accelerating uniformly here. So it is a uniformly accelerated motion. So as this is a uniformly accelerated motion, you can apply the formula to find out the displacement particles. So displacement equation in case of uniformly accelerated motion can be written as S equal to ut plus half a t square. So for particle P, displacement will be nothing but up into t plus half tp, up into tp plus half a into tp square. But in both the cases, initial velocities are 0, so that means initial velocity of particle P, initial velocity of particle Q, that should be 0. So that means this one will become 0. So finally it will be equal to half p into tp square, and here displacement or distance covered is taken as d, considered to be d, because it is said that it is same in both the cases. So it will be d equal to this much. So then the value of tp will be equal to 2d upon ap of 2d upon ap. And similarly for particle Q, this for particle p, for particle q. Clear? We can write similarly, time will be equal to tq equal to 2d upon q, under root 2d upon a. So now what we'll do, we'll take the ratio of these two, it is asked. So the ratio of these two will be equal to tp upon tq root of tp upon okay, simply ratio of these two. So ratio of tp upon tq will be equal to root, so under root t upon p divided by the root 2d upon a q. So over here, root of 2d both will cancel out, so finally how much upon here, so root under root aq upon ap. Now if we check, options are something, options are in terms of mass, so finally what will we do, putting the values of this. So here in this particular case, if we put the values of acceleration, then value of acceleration aq will be nothing but q upon m, q, m subscript q. So of this one whole divided by what is the value of ap? Ap is nothing but qe upon m, p qe upon p, root this p qe both will out, so equal to upon here, so that means under root mp upon m. So ratio of time taken for charge particle p to q will be under root equal to under root mp upon m. Take the option under root mp upon mq, so option C will be the correct one.